Hi. So this week we're going to be working with discrete probability distributions. Now, anytime we look at a discrete probability distribution or any probability distribution, it's describing a population. So for all of the information we're being given this week and next week, we're assuming that we know what the population looks like. So in this first section, the first week that we're working with probability distributions, we're going to be working with discrete ones. And if you remember, discrete values are usually restricted to being whole numbers. They're usually the result of counting. So we need to talk about what a random variable is. And that's abbreviated RV for obvious reasons. That's a variable to which is assigned the random outcome of an experiment. So all that means is that if you sample a different item from that distribution, you're likely to get a different value. So the value of the variable depends on which one or ones you pick. If it's not a random variable, they call it a fixed quantity. So for example, if we look at the time it takes to drive from the Charlotte airport to the Atlanta airport, that's going to be a random variable. Because if you take a different person who's driving, different driving conditions, that value is going to be different. Okay, so it varies based on the sample. Now, by contrast, if we looked at the distance between the Charlotte airport and the Atlanta airport, the distance, the straight line distance, that's going to be a fixed quantity. That value is not going to change based on who's driving or whatever other factors are involved. Okay, so that value is what it is. It doesn't change. So take just a minute and look at each one of these four variables or four quantities and decide if it's a random variable or a fixed quantity. Okay, so pause the video and try to figure out what it is. Alright, so here are the answers. Hopefully those are clear, but let me know if they're not. We can talk about them. Alright, so there are three things that every numeric random variable has. They're the three things that we talked about in the first part of this week's lesson. There's a distribution, a mean, and a standard deviation. So for a discrete random variable, the probability distribution, like we looked at before with the number of rings it takes before a phone answers, the distribution is given as a list of possible values, and then each one of those has an associated probability. So for example, we have X being the number of eggs that are broken in a randomly selected half dozen of eggs. So if we imagine, you've got a quality control technician who's figured out that in all of the half dozen eggs, cartons of eggs, you've got 35% of them, 0.35, have none in them that are broken. And we can see that because that's on the chart. Okay, so X, for an X value of 0, P of X is 0.35. It's also correct to say that of the population, 35% have no eggs broken. Okay, or if we randomly select a carton of 6 eggs, the probability that none will be broken is 0.35, or 35%. So if we were to randomly select a carton of 6 eggs, what's the probability that it has more than 2 eggs broken? Well, that would be the probability that you have 2 or 3 or 4 or 5 or 6 eggs broken. And so you would just add up all of those associated probabilities to get 0.3. So 0.3 would be the answer. All right, so something comes up in some of your homework that's called the rare event rule, where they'll ask you, is something rare? Is it unlikely? And what they're looking for is any probability less than 0.05 is unlikely. So we said for the eggs example, the probability of selecting a carton with 5 broken eggs is 0.04. So that's less than 0.05, so that would be considered a rare event. All right, so there are 2 requirements for a probability distribution. And there's actually a third one, but I wrote 2 here. The first one is that every probability has to be between 0 and 1, including 0 and 1. And then the second one is that all of the probabilities must add up to be exactly 1. The third requirement that I didn't write here is just that all of the values of x have to be numbers. So they can't be like colors or something. So if I gave you a candidate for a probability distribution and asked you if it was valid, you'd look for mainly those 2 things. Do all the probabilities sum to 1, and are they all between 0 and 1? So in this first one, the probabilities sum up to be greater than 1. So that means this is not a valid distribution. In this second example, we have a negative probability, therefore not a probability distribution. Now, what if they gave you a distribution and said, we give you all the values of x and all of the p of x's except for 1. What would be the missing probability? Well, all you have to do, of course, is add up the rest of them, and those add up to 0.9. So if you add up the probabilities that are given, that's 0.9. And then all of the probabilities have to sum to 1, so 0.1 is left over if you subtract 0.9 from 1. So the answer, the missing probability, is 0.1. There are 2 details that come up in your textbook having to do with rounding. If you see 0 plus listed as a probability, you can just treat that as 0. It just means the probability is so small that it rounds to 0 to several decimal places. So just treat it 0 plus as 0. Now, the other thing is when the probabilities are rounded, it's possible that the sum of the probabilities may be just a little bit off from 1. As long as it's not too far off, like about 0.01, it's okay. All right, so now let's look at the mean. Remember, probability distributions are for the population, so that means the symbol for the mean is going to be mu rather than x bar. One thing I really want to talk about here is the mean of a probability distribution is essentially a weighted mean. So a weighted mean, like for example, the way I figure your grades in this class. So your x values might be your grades on test 1, test 2, your MyStatLab average, etc. And then the weights, the p of x's, would be how much of your grade that counts. And that would be I'd figure your average exactly the same way as we're doing this mean right here. So to find that mean, we're going to take every x and multiply by its associated probability. And then once we do that, we take the sum, and that's all there is to it. So here's our eggs example. We just take every x, multiply it by the p of x in the same row, and then add up the results. I do have a typo here. So the mean number of eggs should be 1.59, I believe. Okay, so our mean here is 1.59. So now we need to find the standard deviation. And this is a good time for me to tell you about my philosophy with hand calculations. My philosophy is that I will ask you to do hand calculations only in situations where I think doing so will help you understand the material. So doing the weighted mean, I think if you do that by hand, it helps you see what's going on. The standard deviation is just tedious, so I'm just going to let you get that from StatCrunch. I'll make a video about how to find that value in StatCrunch. But here's what that looks like. So when we do this in StatCrunch, we get some output. This verifies that the mean is 1.59, like we thought, and the standard deviation comes out to be 1.7268. Okay, and again, see the StatCrunch video for how to get that. One more thing, and that's the variance. To get the variance, you just take the standard deviation and square it. So we got a standard deviation of 1.7268. If we square that, we get the variance. And we don't talk about it very much because it's not very useful, but it's in your MyStatLab homework. One other thing I want to go back and mention is with the standard deviation, the notation for the standard deviation of a population, and that's what we're looking at here, is sigma. So it's a Greek letter, lowercase sigma. That's what this thing that looks like an O is. Okay, it's called sigma. All right, so that's it.